Hello everyone, this is Komodo. Would like to introduce Apache Spark and use it to deal with our million songs dataset. Apache Spark is an open source cluster computing framework, and it's a faster and general engine for large scale data processing. Generally speaking, it's a data management tool and contains features of database management system. It performs well in distributed system and distributed storage. Here are the four reasons why we choose Apache Spark. The first is speed, 100 faster than Hadoop in memory and 10 times faster on disk. And also it's easy to use. We can write applications quickly in either Java, Scala, Python, or R. And we can combine SQL streaming and all the other libraries seamlessly in one application. Also, Spark runs everywhere. Here are our four goals for our mini project. We'd like to perform data analytics operation. We'd like to maximize distributed computing capability and the capability of accessing distributed file system. And we also like to perform tasks such as projection, aggregation in Spark.
Okay, I will talk about our applications detailedly. And our application is about a million song data size. It's totally including like 280 gigabytes data. And what we are doing is working on a part of it is like 25 gigabytes. And it's a link to our data site. And let's look at our data set. Our data set have a lot of fields, and for each field, it was stored by the HDF5 binary field. And for our data size, there are lots of attributes, and we are using 5 attributes inside. And it is artist name, and artist term, and the hotness, and the year of the songs, and the duration of songs. And what our task doing is like we are going to query the music based on the release year, and we will calculate the average hotness of the artist based on the hottest rate of their music, and we also will compute the average song duration of each artist. Finally, we'll aggregate the terms and count the total. And this is our Spark architecture. We including one Spark manager and 3 workers, and our data is stored in the HDFS. And then it's a general requirements. We are using 5 tools here.
For Spark installation, you can go directly to the Spark website and download the zip file there. And you put it in the folder and extract the zip file. It's very easy. But you also need to add the environment variable in the bash profile. So you need to add path. After that, we need to install the Hadoop as well. So we store all data into Hadoop. So you can download it in the Hadoop website here. So you can just copy paste it and again extract the Hadoop installer. One thing that you need to configure here is sdfs.xml, Hadoop environment.sh, and coresat.xml. This is the example of the configuration. We will put this configuration file into the GitHub directory as well. Because Hadoop and Spark doesn't support H5 binary file, so we need to make a Python script to convert the binary file into JSON format. So we download just 3 sets here. For each set, it consumes about 7.7 gigabytes. For the Python script, to convert the binary file to JSON, we put it in the GitHub directory. So the script is musics@gfs ingester, and it will produce 3 files for each set, and we ingest those files into SDFS using Hadoop file system copy from local. So it will copy the data into Hadoop. Because we want to simulate 3 workers and 1 manager in one server, we need to configure the Spark env.sh. So we add Spark worker instances here with the configuration. We set it to 3 to run 3 workers, and for each workers we assign 3 GB of memory. Now, this is the most important thing in Spark configuration. You need to configure Spark defaults.config if you process more than 1 GB of data. Otherwise, you will result in out of memory heap space. So we configure the spark.driver.memory with 4 GB and spark.executormemory.4 GB. And to start the Spark, we can go directly to the VM here, and we already put all the application in apps directory. Okay, this is the Spark installation and Hadoop installation. We started using start master.sh. Remember that we already put our path directory, path environment variable. So we can call start master.sh. It's running. Let's see. And to check if it's running well, we can go to the browser and put the IP address with port 8080 to check the manager. We can see the URL here for Spark, which we will use to run the Spark slave. We see there is no slave yet, right? There is no workers. So we can run the start slave to run the worker and put the master URL here, and it will run the workers. We can check, yeah, the workers running and live. Okay, Spark runs well. Okay, now we go to the code. What I want to state here is we are using Spark SQL to execute the first and second task. So we see here in the first task, okay, here, this is the SQL statement that we use to select the artist name and the count of the artist and group it by year. And for the second task, we make again the aggregation for the artist name and the average of hotness and duration. However, for the third task, we can't use Spark SQL. Why? Because terms is an array of strings, an element inside elements. We can see here, therefore, we use the classical map reduce operation for this. Okay? Let's see if it can run or not. To run the code, we can just download the file from the GitHub using git clone. And yeah, it's already downloaded. And this is our directory. We go directly to the Scala and find pom.xml. So this pom.xml is Maven project. And we do Maven install. So Maven install, we download all the library and also compile the Scala source into a jar. Yeah. So the result will be on this target directory. Okay. The Spark Music DS.jar is the output of our compilation. To run this to Spark master, we can call Spark submit, and it's already here in the presentation slide, and just run it. Okay, and I think there is no problem here. We can see it's running, and we can check it in the manager. So one advantage of using manager, if you can monitor your Spark application in details. Now, this is the example. So we see here that 3 executors added because we use 3 workers. So Spark distributedly dispatch all the process into the executor. Oh, what is this? This red line or red box, it's showing that one of our executor is bleeds because of heap memory space. But Spark task failure tolerance manage this failure and dispatch the operation or job into another executor. So it will, although it failed in some workers, it still can run in other workers. Now, if I refresh it again, something happened here, but Spark will still doing it well. So this is the simulation proof that Spark can run well even though one executor or one worker is failed. We can see here that our execution is finished. And this is the output. First, we check the artist song output, the txt. What is shown here is, wow, okay. From this information, we know that Boyzone produced 5 music in 2010. This will show all the artists' songs produced in particular year. And this is for the artist hotness. Oh, Kanye West, yeah, absolutely. And Coldplay, yeah. And this is for terms count. Okay, based on this information, I can deduce that rock is a popular term among the artists, followed by electronic and pop. So these are the output of our job, and now we go to the future work.
As we talked previously, Spark is really doing a good job on the parallel processing. So that's also the reason we get a so quick response from 24 gigabyte file dataset. And as highlighted here in the red zone, this is the structure we are using for this project. The Spark SQL, Spark Core, standalone, Hadoop distributed file system. Outside this area, there is a lot of extension library that can enable Spark to do a lot of tasks. MLib is a library for the machine learning. It uses the parallel processing feature of Spark very well. GraphX is a graph computation system that combines the ETL exploratory analysis and the iterative graph computation. Spark Streaming can process data from various sources. Outside these extension libraries, Spark is working well with a lot of data analysis tools, such as R. When combined with Spark, R can analyze large-scale data by using distributed computation engine from R shell. Okay, that is our video. Thanks for watching. This is Komodo.